Here's the problem of determining what is the probability of winning at craps. We have a little picture here of two dice and a crap table, a probability model of the sum of two dice, six-sided dice. So we have 36 outcomes, outcomes from 2 to 12, and summary of the rules of playing craps. Now, there's two possible ways of winning at craps. First, you would have to roll either a 7 or 11, and then you would win. And likewise, if you rolled a 2, 3, or 12, you would lose on the first roll. And then the second option of winning is if none of those numbers come up, so you're left with the numbers 4, 4, 5, 6, 8, 9, and 10, you would go into the second option of winning. So if you roll these on the first roll, they become, that number is what we call in craps your point number. And then you have to try to roll that again before you roll a 7. So in this scenario, you don't want to get a 7. You want to roll one of these numbers before. So in writing this out, looking at this, we're looking at, the probability to, win is going to equal, two different probabilities combined. So you win on the first roll plus the probability of you win in some roll after the first. Kind of an informal way of looking at how to set the probability. And now from this point we want to get a little more formal and to use our rules of probability to make sense of this. So what we're looking at here now, let's change the color a little bit, is so we're looking at the probability to win on the first roll. So it's the probability of you roll a 7 or 11 plus the probability that you roll a 4, 5, 6, 8, 9, or 10, and then you roll the point number before 7. So a little more technical jargon, a little more way to form the probability. Well, what is the probability of getting a, let's change the color a little bit. What's the probability of getting a 7 or 11? Well, easy enough. So from this point here, we would look at, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 outcomes that would give us the win out of 36. So the first scenario would just be simply 8 out of 36. Now we want to look at the other possibilities of 4, 5, 6, 8, 9, or 10. So we're looking at how would we get that? It would be the probability of, if we just, let's start with 4, the probability of 4 and the probability that you would have 4 before 7. Now this part here, to make it a little more formal, would be what's the probability of getting a 4? Well, there's 1, 2, 3. So that would be 3 out of 36. And then the probability of getting 4 before 7. Well, we just keep on rolling until either one of those numbers come up, 4 or 7. And so our sample space is essentially the 6 sevens and the 3 fours. So that would be out of 9. And since we only have 3 fours, it would be and 3 ninths. And since it's, and they're independent events, we would just multiply those for that part here. And then likewise, for the probability of getting, let's say 5 is your point number. So we want to look at what's the probability of getting a 5 and the probability of 5 before 7. Oops. And this time we have 4 out of 36 times, and it's going to be 4 out of 10. And so putting this together, we would have, continue on with the probability of getting 6. If that is our point number, is going to be the same as probability of 6 and the probability of 6 before 7. And this time we have 5 out of 36 times 5 out of 11. And if you continue on, if you notice 6 is here, 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 here. When we go to investigate the probability, if 8 is our point number, we would have 1, 2, 3, 4, 5. So it's going to be the same as all this here. So it's just going to be repeating. 8 would be 536 times 5 over 11. And then likewise with 5 has 1, 2, 3, 4. 9 also has 1, 2, 3, 4. 4 has 3 outcomes, 10 has 3 outcomes, so it's going to be all this pretty much doubled. So we want to set this up as 8 out of 36 plus doubling or multiplying. Let's see, 3 out of 36 for 4 times 3 out of 9. I guess we can do this. Plus 4 out of 36 times 4 out of 10 plus 5 out of 36 times 5 over 11. And with the calculator, help of a calculator, it would be roughly 0.4929. So a little less than 50% chance of winning. And the chances of losing are going to be a little over 50%. So in the long run, if let's say a casino plays this game thousands and thousands of times, they will come out ahead. But this is a good model, a good situation of how to find a rather complex probability problem using different rules of probability.